All right, geometry guys. I can't see you today, so I'm going to make sure that you have the lesson that you need. Um, this won't take you very long at all. It's actually something that you might already know, and so I'm going to go back over this again, and you're going to go ahead and make sure that you remember it and you do the work. And all I'm going to expect you to do is this paper, and then you'll have probably have some free time on your hands. Um, this is the topic of this is slope of lines. What is slope? Oh my gosh. Let's go all the way back to Algebra 1. You remember those days last year. It's really super simple, right? The slope of a line. The slope is just the steepness of a line, right? You have a line that has a positive slope here. It really shoots up from left to right. It has a slope of 1, and this has a negative slope. It's going down from left to right. That's really just, we're figuring out what the steepness is, and we have a formula that goes with it. The formula for m, or slope, is y2 minus y1 over x2 minus x1. That's the rise over the run. I guess I could write that next to it. The rise over the run, right? So slope is, m is also the rise, the change in y over the run, which is the change in x, right? The change in up or down divided by the change in across. And it's really quite simple. So there's your big idea there. There's your formula. I'll rewrite the formula when we get there. There are examples here. They're pretty easy. You can see the examples for yourselves. What I want to do is go ahead and do one or two of the problems on your sheet, because it'll be easier to understand. Here we go. Maybe I'll do a couple of them. I'll give you something else to look at as well. All right, so if my formula for slope we just wrote is, I'll write it bigger so you can see it, m equals y2 minus y1 all over x2 minus x1. There you go. See, it's nice and big so you can see it. And let's just go ahead and use these guys here. We'll call this coordinate pair 1. We'll call this coordinate pair 2. And this is 0, 0, and negative 2, 8. Okay? And so in this coordinate pair here, y2 is 8, right? See the y in coordinate pair number 2 is 8. And we're going to subtract from it 0. All right, and then we'll take a look over there. Negative 2 is our x coordinate of our second pair minus 0. All right, and what we'll have is 8 over negative 2, which is negative 4. So it has a very steep downward slope. That's what it says. It's going down from left to right, and it's pretty darn steep. If you look at this, you put a dot here and go down 4 and over 1. And you see that this line would be super steep. 1, 2, 3, 4 would be right there. That's a super steep line compared to all these lines here, right? Good. All right. I'll do another one. So this is number 1. That's number 1, sorry. This is just a formula. This is number 1. And let's do, let's do number 2 because it has lots of negatives in it and you guys hate negatives. So number 2, we're going to say that this is coordinate pairs number 1, coordinate pair number 2, and this is negative 2, negative 3, and 3, and negative 5. Good. Okay, so we'll start putting this stuff in. Y2 is -5, right? There's the second, the y in the second pair. And y1 is -3 minus -3 all over the x in the first one, which is 3, and then minus a -2. Right now we have to do some math, and of course, minus a negative is plus a positive. So -5 plus 3 is 2. And then 3 minus a -2 is 3 plus 2, which is 5. So this slope here would be up to and over 5. It would be a very shallow slope, right? 2/5, a fractional slope. You can see it here. I'll just draw it on here so you can see it up to and over 5. And that's 5 right there. Okay. Good. Okay. And then we would try and draw a line through it. It would look like that. It's a pretty shallow slope, right? Good. All right. Well, that's how you do that section there. And then there are a myriad of ways of finding your slope when you're looking at a graph. And for those of you who don't like to see lots of lines all over a graph, this is going to drive you crazy, but I think we're going to survive it. I want to do two things. I want to, or is it AE? AE I want to do. I want to do, I think it's EM. Yeah, and EM I want to do. And then we'll just go ahead and do AB. These two things are special, right? And they have to do with a 0. When you do this math, I think you can see in the definition of the slope formula up at the top, it says x2 and x1 can't be the same value. And I'm going to show you why that is because if this is the same as this, your denominator would be 0. And of course, you cannot divide by 0. It doesn't exist. Even though this isn't just a fraction, it's your rise over your run. It tells you it's a ratio. You can't have 0 run because you'd have a vertical line, and that is an undefined slope. So I'll explain that when I get there, and then we'll move on to the next step. Let's look at AB, and I'm going to outline AB for you. This is point A here, and where's point B? Point B is here. So we're looking at this line right here, okay? So you could do one of two things. You can find where this line intersections, right? And you can count, right? The counting method is valid. I don't see anything wrong with counting. Yes, you can use this, right? You can find two coordinate pairs. You could say that A is coordinate pair 1 and B is coordinate pair 2. And you can do that math. And we're going to do both ways, but I'm going to show you the easy way first. The easy way is to count from this intersection to this intersection, or you can count all the way up and over. If you want to count all the way up, it's 1, 2, 3, 4, 5, 6 spaces up. That's 6 spaces up from here to here. And then over 2 spaces. So it has a rise of 6 and a run of 2. So our slope obviously is 3, right? When we simplify 6 divided by 2, we have a slope of 3. Now, I'm going to use this formula and do the same thing. I'm going to take these two coordinate pairs just like it says, and I'm going to do some math. Y2 is 4, minus y1 is -2. And x2 is 0, then minus another -2. That's our x1, right? So if we do this math, 4 minus a -2, that's 4 plus 2, which is 6. And then 0 minus -2 is 0 plus 2. So we have 2. Are these two things the same? Yeah, we could have counted. And it's just as easy. So if you know both things, that's super awesome, and we're ready to go. The other thing I want to show you is when you have, sorry, I just erased the formula by mistake, but I'm going to be moving this whole thing in a minute. I want to talk about EM. EM is this guy here. EM is that one that has x's that are the same, right? And we would do the math, and we'd have 4 minus 4. Well, 4 minus 4 is 0, and we cannot have that. And what that means is that a vertical line has an undefined slope. And that undefined slope means that you can't list a slope. It means it's just undefined. So here I would write, I could put the empty set there, or I could just write undefined. All right, or UND means undefined. That's pretty good. You can do that as well. The next one I want to look at, or the last one I want to look at on this page, is AE. AE is this guy here. Here's A, and here's E, and we have a horizontal line, right? And what that means is that our Y's are the same. And if our Y's are the same, that's okay, because it means I just have a 0 up here, right? If I have -2 minus -2, -2 minus a -2, which is -2 plus 2, and that gives me 0, right? That's okay. It just means it doesn't go up. It just goes over infinitely. We have a horizontal line, all right? So 0 in the numerator, okay. That means it's a slope of 0. 0 in the denominator, no good. That is undefined, or our empty set. I'm going to move on to the other side. We'll excuse the young gentleman who just jumped into the video for a brief moment, and we'll move on. All right, let's go to the back side. This is where all the fun begins, right? This is where our new topic begins. You may or may not have heard this, and I'm going to talk about it real briefly. We're going to use the formula, and we're going to compare slopes. This is the geometry portion of talking about slope. We talk about slope in geometry when we want to talk about whether lines are parallel, or whether they're perpendicular, or whether they're neither. And so the definition is if the slopes are the same, if the two lines have the same slope, right? Same slope, they're parallel. Cool? And this next one says two lines are perpendicular if their product is -1. Real mathematicians say that perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. Let me write that out. Negative reciprocal slopes. All right. And if you remember, you have a fraction 1/2. It's reciprocal, right? 1/2, and its reciprocal is 2 over 1 or 2, right? That's the reciprocal. We just flip it over. Good? Good? Just turn this sucker on its head. That's its reciprocal. Good? Now, the negative reciprocal would be -2, right? It'd be the opposite of what you see as well as its reciprocal. Good? All right. And if you look, just like that definition says up there, if you multiply these two things, their product is -1. But you already know that. And I'm going to move on, and we're going to take a look at some real problems here, problems on the page. Hopefully this won't be in my way. If it is, I'll erase it. If not, I won't. How'd you like the cleaner coming through while I was trying to make a video? Didn't even recognize I was making a video. Crazy. Anyway, this will be good. I'll get rid of that. Hopefully you wrote that down. Writing that down is very, very important. So here we go. We're going to look at MN and RS, right? This is one line. This is one slope. And then this will be the other slope. And we'll go ahead and compare. Okay, can we do that math together? All right, so let's do MN. We have M equals the slope of this one in purple is equal to 4 minus 3 over 2 minus 0, right? 4 minus 3 over 2 minus 0. Well, that is just simply 1/2 or 1 over 2. It goes up 1 and over 2 every time. Now, I'm going to do this in red. Just give me a chance to open this sucker up. Here we go. 4 minus 1, right? 4 minus 1 all over 8 minus 2. 8 minus 2. Well, look at that. That's 3 over 6, which is the same as 1 over 2. These two slopes are the same. So, hey, what does it say? I guess I'll write it here. Same equals parallel, negative reciprocal equals perpendicular. Let's do that. How's that? Look pretty good? You can see it, can't you? And then I'll do one last one. Let me try number 4. What the heck? I have enough space over there, so I'm going to do it over here. Then I can erase and do the next part. Here we go. And our slope, -7 minus -3, -7 minus -3 over -2 minus 0. Cool? Sound good? All right. -7 minus a -3. -7 plus 3 is -4. -2 minus nothing is still -2. So our slope is 2. 2 negatives make a positive, right? Right. You divide a negative by another negative, you get a positive. Good. Now, I moved over into that space because I saw that I had enough space to write to the right of it. So, well, it takes me a year and a half to open this pen because I'm old and weak. I'm going to write it out here. So n is going to be equal to -3 minus 1. -3 minus 1. Oh, look at that. And then 0 minus 2. Oh, my goodness. Shoot, these things are parallel again. Darn it. -3 minus 1 is -4. 0 minus 2 is -2. we have another slope of -2. Therefore, these two things are parallel as well. These are parallel, these are parallel. I didn't get to one that was perpendicular. Let's go ahead and cheat on this guy here. Is that okay? Can I show you some legal cheating in geometry or mathematics? Here we go. I'm going to erase this so I can move the picture up. We can do some math at the bottom of the page. I have it in my hand, for goodness sake. You crazy person. All right, so we get a slope, right? And we get a point. And then we're just asked to graph, right? Graph the line that satisfies this condition. So we go over 6. 1, 2, 3, 4, 5, 6. I think that's 6 and up 2. We make a dot. We started at the origin. Let's think about that. Then I'm running over here to grab my straight edge. I didn't run away. Then we connect the dots as best we can. Does it have to be perfect? Nah. Sound good? There's my line for number 5. Now, the cool thing about this is I could just say 5 is purple and then start changing colors with the other one. Now, we have to do some math with this one, right? With those points. And the reason they give you those points is they want you to find the slope. Well, they want you to find the slope of this and then create a perpendicular slope to that. All right, well, let's go ahead and find the slope of AG, right? So the slope, I'll put it up here, is -2 minus 6 over -1 minus a -5. All right, -2 minus 6 gives me a -8. -1 plus 5 gives me 4. Good? So -8 over 4 is -2. All right? That's my slope for AG, but I want a perpendicular slope to AG. And we said that the perpendicular slope is the negative reciprocal of the slope that we're given. So if our slope is 2, that'd be 2 over 1, right? -2 over 1. Well, the negative version, the perpendicular slope, would be the positive version just flipped over. So it would be 1/2. So I have a slope of 1/2 that passes through over 8 up 5. Now, this is 6, this is 8, 3, 4, 5, right? And my slope is a positive 1/2. So I go up 1 and over 2. I'm going to go down 1 and back 2 because that's how I cheat. Sound good? I made a couple of dots there. I get my straight edge out. And let's see where this bad boy goes. There we go. And then I connect the dots, and there we go. So this is the one in red. There it is. I'm so old. All right, and last, but certainly not least, parallel means they had the same slope. So you try that one on your own. There it is. You finish those few problems, and then I'll give you a homework sheet to work on, and you should be good to go. Thank you so much for your time. This is a nice, easy piece of work to do. Congratulations, you got something easy to do. If you have any questions, please send me a message. I'll see what I can do to help you out with it. Thanks for your time. And this is the end.